Hello, welcome you all for the next session. Especially, we are discussing here on the electronic actuators, normally what we are using in the mechanical applications. In that, the first what we are discussing is the diode. What is a diode? A semiconductor device with a two terminals allowing the flow of current in one direction only. Normally, the diode is made up of silicon and germanium. The two are the most common single elements that are used to make the diode. Silicon and germanium are both group 4 elements, means that have 4 valence electrons. Their structure allows them to grow in a shape called a diamond lattice. Gallium is a group 3 element, while arsenide is a group 5 element. When put together as a compound, GaAs creates a zinc blende lattice structure. Even this is also another form of diode. Next, diode consists of the two junctions. One is N junction, the another one is the P junction. N type, when a small amount of pentavalent impurity is added to a pure semiconductor, it is known as N type semiconductor. Next one, P type semiconductor. When a small amount of trivalent impurity is added to a pure semiconductor, then it is called as P type semiconductor. Now, light emitting diode. Light emitting diode is also another one form of diode in which it acts as a switch. Once if the switch is on, automatically it will close. Light emitting diode is a two lead semiconductor light source. It is a PN junction diode which emits light when activated. When a suitable voltage is applied to leads, electrons are able to recombine with the electron holes with a device releasing energy in the form of photons. This effect is called as electroluminescence, and the color of the light is determined by the energy band gap of the semiconductor. Electrical actuator. In this electrical actuator, thyristor is also one of the actuator. Thyristor is a solid state semiconductor device with a four-layer alternate P and N type materials. It acts exclusively as bistable switch conducting when the gate receives a current, triggers and continues to conduct until the voltage across the device is reversed bias or until the voltage is removed. This is a schematic diagram of the thyristor. A 3-lead thyristor designed to control a large current of anode to cathode path by controlling that the current is the smaller current of its other leads known as the gate. The main applications are ETO devices are used for fault current limiters and solid state circuit breakers. Because of the high capability, the current interruption, fast switching speed, compact structure and low conduction losses. The next one is the relays. Relays are the switches that opens and closes the circuits electromechanically or electronically. The relays controls one electrical circuit by opening and closing contacts in another circuit. When relay contact is normally open, no, there is open contact when the relay is not energized. When the relay comes in contact, normally closed. There is a closed contact when the relay is not energized. In either of the cases, applying the electrical current, the contact will change their state. The relay consists of an electromagnet and also a set of contacts. A relay is used when the circuit is to be controlled at low power signals. Relay are often grouped together or with other components like fuses. Relay is also another type of switches. The application of the relay is amplifying the digital signals, switching a large amount of power when a small operating power, isolating the collecting circuit from the control circuit when the two are at different potential. In logic function and even in the time delay functions, the relays are used for switching on and off. The next one, the piezoelectricity. Even the piezoelectric crystals can also be used as an actuation system in the electronic devices. Piezoelectricity is the electric charge that accumulates in a certain solid material in response to the mechanical stress. There are n number of materials are used for the piezoelectric actuations. Quartz is a very best and simple example. Normally what they are using it as a piezoelectric material, but other materials are berlinite sources and topaz lead titanate. What is an actuator? An actuator is a device used to produce actuation. Actuator is a mechanism by which the control system acts upon environment. Environment means when it is required, then it switches on. When it is not required, it switches off. The actuator's output is usually mechanical, either it may be a linear displacement or velocity or even the rotary also. The actuations be from a few microns to a few meters. The main attribute of the actuation, the size of the operating force and the torque, the operating environment, linear or rotational movement, the energy sources, the speed of the response and motion, the amount of the movement need, the degree of the precision need, the method of control and monitoring. Now, piezoelectric actuators is a device that makes use of the inverse piezoelectric effect, generates mechanical energy when subjected to electric energy. It means that once if the piezoelectric crystal is given a small electrical shock, then the piezoelectric crystal starts expanding it. Once if the electric charge is removed, automatically it contracts. The expansion and the contract of the piezoelectric crystal leads to an actuation. The piezoelectric materials are having this characteristics, have a short response time, ability to create a high force, higher displacement accuracy and high energy accuracy can be achieved in the case of the piezo actuators. The main disadvantages of the piezo actuations are have a small strain, have high supply voltage needed, large hysteresis. The main applications are hand blurring correction in a digital camera or ultra precision mass flow control. This figure shows that ultra precision mass control. In this there is the flow of the water or it may be oil. It can be controlled by means of the piezoelectric actuators. Once if the piezoelectric actuator is charged, automatically it expands. Once it expands, the diaphragm closes. Once if the diaphragm closes, automatically the flow of the liquid minimizes. The same way, once if the charge is removed, automatically the diaphragm contracts. Because of the contraction, the gap between the wall automatically increases and the flow rate increases. The next one, SMA actuators. SMA actuators are nothing but the shape memory alloy actuators. The shape memory alloy is an alloy that remembers its original shape even after deformation. This material is a lightweight solid state alternative to conventional actuators such as hydraulic, pneumatic, or even motor-based system. Shape memory alloys are having many applications in robotics, automotive, aerospace, and biomedical application. As it is having the two different effects, one-way shape memory effect and as well as the two-way shape memory effect, the shape memory alloys are having a major application in the actuators. The main application of the shape memory actuators are in the aircraft, space industries, automotive industries, biomedical industries, even in the piping and even medical industries. These are all the some of the industries where the shape memory alloys are used as an actuator which can actuate very easily at low temperatures. One of the successful application is the temperature sensitive governing valve which controls the shifting the pressure in automatic transmission. Consequently, the steel spring can be compressed the nitinol spring pushing the movable piston of the valve into a closed position for this a particular application. When the temperature of the transmission and the transmission fluid increases to the operating temperature, the nitinol shape memory spring is a martensitic state expands overcoming the steel spring force and eventually pushing the piston into open position. In this schematic diagram, it consists of the two things. One is a steel spring, the another one is a nitinol spring. The opening of the port, the inlet port and as well as the outlet port, it can be done very easily by giving a small amount of heat into the nitinol spring. Once if a small amount of heat is given to the nitinol spring, the expansion takes place, and if the heat is removed, automatically the contraction will take place. Depending upon the expansion and as well as the contraction of the spring, the the plunger will starts moving right and as well as left. Once if it starts moving towards the left, as the plunger is having a stepped portion, through that stepped portion automatically the port will be opened and the fluid flow will takes place. Once if it is under contraction, the stepped portion will be moved towards left, which is blocking the fluid flow. Many exciting applications of the SMA comes from the field of robotics, which shares many common points with the deployable structures. Many SMA based joint actuators have been proposed. The joints can rotate back and forth by heating to nitinol spring. Alternatively, the cooling of the liquid was used to improve. This hinge is one of the best example for the expansion and as well as the contraction of the hinge by using a nitinol wire can be achieved, and we can use this as a best example in the deployable structures in the space industries. By this we can say that SMA actuators are having a better applications. Thank you.